1.1 is C and 1.2 is A, and then all the others remain as they are. At the end of each and every question, colleagues, I'm going to allow you to raise your hands so that we can maybe attend to logistics that you want us to attend to. Let us do so now. Question 1.
Question 1, Mezapi, you are saying the answer at 1.1
is C.
C, and then now A for 1.2. Okay.
Yes.
Okay, Mezapi, thank you very much. Maybe your pace should be very slow at times, so that maybe we can be able to capture if there are any changes. But colleagues, I don't see any hands regarding now question 1. So Mezapi, I feel now it's easy for us. Okay, there's a hand now from Ansi. Ansi, kindly open your mic and then comment on question 1.
Sorry, 1.2 you said is, what is the answer?
The answer is A.
A, thank you, sir.
Thank you very much, Ansi. Thank you very much, colleagues. Those now are the changes that we have in question 1. 1.1 is C, 1.2 is A, and the rest now remains the same. Mezapi, I feel we can go now to question number 2.
Thank you, Ndate. Question 2.1 was saying convert 0.0000074141 to scientific notation for 2 marks. It is the answer will be 7.141 multiplied by 10 to the power negative 7. And 2.2 was saying convert 35 multiplied by 10 to the power positive 3 from scientific notation to a normal or a standard notation. The answer is 35000.
Kindly move, sorry Zapi, kindly move your memo up, because now you are still at question 1. We are referring to question 2, but we do not see the answers. Thank you very much, Mezapi.
Thank you, Dr. Nambane. Okay. And 2.3.1 was saying convert the following 62000 grams to kilograms. For 1 mark, it will be, if Elena had written 620,000 divided by 1,000 equals to 62 kilograms. Or if Elena had written just 62 kilograms, that is 1 mark. And 632, 3 hours 2 seconds. It is 3 multiplied by 60 multiplied by 60, which gives us 10,800. 1 mark for 3 multiplied by 60 multiplied by 60. 1 mark for the whole thing. 3 multiplied by 60 multiplied by 60 equals to 10,800 seconds. The second mark for 10,800 seconds. Question 2.3.3, 63,000 centimeters to meters. It is 63,000 divided by 100, which gives us 630 meters. 1 meter only for 1 mark only for the answer. For 630 meters, 1 mark. And question 2.4 was saying a grade 10 learner weighing 72,000 grams decides to start losing weight by carrying all the grade 10 books, which weighs 2,000 grams, and from school each day. The distance between home and school is 63,000 centimeters. 2.4.1 says calculate the total distance that the learner covers in meters for the trip to school and back home each day. It will be 63,000 multiplied by 2, 1 mark, equals to 126,000 divided by 100, 1 mark. The last one will be 1,260, 1 mark, meters, 1 mark. 1,260, 1 mark. 3 marks for 2.4.1. 2.4.2, the learner then loses 1.5 kilograms each day. How many days will it take for the learner to reach the aspired weight of 54,000 grams? The weight loss equals to 72,000 minus 54,000, which equals to 18,000 grams. Therefore, 1.5 grams equals kilograms equals to 1,500 grams. The number of days will be equaling to 18,000 divided by 1,500, which equals to 12 days. It is 1 mark for the weight loss, 72,000 minus 54,000. 1 mark for 1 mark for 12 days. That gives us 4 marks. The total for the question is 14.
Thank you very much.
Any questions?
Thank you very much, Mezapi. Colleagues, any questions relating now to question 2? Inputs, suggestions? Hlaba Spesihle? Mehlaba?
Good morning.
Good morning,
Can you hear
Mehlaba.
me, sir?
100% me.
Yes. Yes. I just logged in. I was struggling. So I just want to ask, they have a 2.4.1.
2.4.1.
Yes. There is a mark for saying 63,000 times 2, and then your final answer dividing by 100 to make it meters. So I want to ask, can we give a mark if they started first dividing the 63,000 by 100 to make it meters? Then they lose a mark where they had to times it by 2.
Okay. Let me quickly write it down and confirm. Okay, so basically they are going to lose now. You must follow with me, Mezapi. The question is now the learner instead of multiplying it by 2, they just say now 63,000 divided by 100, which will give them now meters. But now they are going to lose a mark for the final answer and the mark for multiply by 2. So it means you can only give a mark for 100, which is now the conversion of centimeters to meters.
Yes.
So Mehlaba, the agreement is, and colleagues, we can give that 1 mark of converting from centimeters to meters by dividing by 100. But now it cannot be any number. It should be specifically the 63,000 divided by 100. Then they will use a mark for multiplying by 2, and they will lose a mark now for the final answer. Happy, Mehlaba?
Yes, I am.
Thank you very much. Mezapi, I am also at now 232. Let's maybe check 232. That mark of 3 multiplied by 60 multiplied by 60, is it the mark for 60 multiplied by 60?
For 3 multiplied by 60 multiplied by 60.
So it's basically for the whole
For the whole thing.
For the whole
Yes.
thing. It's not for the 60
60.
only. So now if I have a learner who decided to say 3 multiplied by 3,600, we can basically still award a mark because it's now 60 multiplied by 60.
Yes.
100%. So colleagues, there's another option there at 232. Basically, a learner now decided to multiply 60 by 60 to get now 3,600. So it will be 3 multiplied by 3,600. It will give you now still 10,800 seconds. Any inputs, comments on question 2? If there's none, then I believe that we can be okay. Mehlaba siphe sihle. Mehlaba. Mehlaba, your hand is up, or is it an old hand?
Oh, Askis, can you hear me now?
Yes, we can hear you, me.
I was saying 2.3.1.
2.3.1. Yes.
Yes. I want to ask about the units. Most the question says they should change grams to kilogram. So do we give a mark or we don't give a mark if they just go to 62 without writing the unit kg?
Mezapi?
Like for all the questions, the seconds, the meters as well, if they just put the answers.
Okay. Mezapi?
If the learner had written just 62,
because they were told to convert it to kg.
convert from grams to kilograms, yes, we can give a mark.
Yeah, I
Yes.
also believe so.
So we can put the unit inside brackets.
So colleagues, for all the questions of question 2, let's put the SI units into brackets. Even if they are not there, the learner will still now get the marks. Very, very important, because basically we told them that they must convert to seconds, to meters, and to kg. Thank you very much for that, Mehlaba. Thank you very much, Mezapi. I think we have exhausted it. We can now basically go to question 3, Mezapi. Or Mehlaba, is it a new hand also?
No, it's not a new event.
Okay, thank you very much. No problem at all. Mezapi, we can go to question 3. Thank you very much.
Thank you. Question 3 reads as follows. A learner walks from point A around the north inside a lake to point B. The learner walks 300 meters north, then 300 meters east, and then 600 meters at the bearing of 135 degrees in 10 minutes. 3.1 was saying define the term resultant force. A resultant force, the answer for that, for 3.1, resultant force is a single vector which can produce the same effect as 2 or more vectors acting together. The acting together is in bracket. If Elena had written, it is a single vector which can produce the same effect as 2 or more vectors.
Mezapi, sorry ma'am,
Yes.
kindly move up your memo to question 3.
Am I reading from?
You're reading from the one in your hand, Mezapi. Thank you very much.
So, reading from the one in my hand, Dr. Nambane. Thank you very much. It is a single vector which can produce the same effect as 2 or more vectors. 2 marks for that. 3.2 was saying determine using accurate scale diagram what the learner's final displacement is from point A to point B. Use the scale 1 centimeter equals to 100 meters. Here, a learner should start by saying scale 1 centimeter equals to 100 meters, and then draw the vectors of 300 north and then 300 east, head to tail, and then from the tail of the 300 east write 600 meters at a bearing of 135 degrees, and then the vector will be the resultant will be 734.6 meters. We are going to award the marks as follows. The first mark for the 300 meters, which will be 3 centimeters north, and the second one for the 300 meters, which will be 3 centimeters east. The third mark for the 600 meters, which is 600 centimeters at a bearing of 135 degrees. And the last mark for the resultant, which will be 734.6 or 7.3 centimeters at a bearing of 99.7 degrees. The range for the resultant can be 362 to 360, 732 to 736 meters. And the range for the angle can be 98 to 100 degrees. And then 3.3 was as follows. On what bearing must the learner pedal back to point A if the learner takes the boat at point B? It is 1.7 degrees plus 90 degrees plus 180 degrees. That all together, which will give 279.7 degrees. 2 marks for that. That is 3 marks. 3.4. Calculate the average speed with which the learner was walking from point A to point B. Speed equals to distance divided by time, which equals to 1,200 divided by 10 multiplied by 60, which gives us 2 meters per second. 1 mark for the formula, 1 mark for the substitution, and 1 mark for the final answer with the SI unit. Any questions, colleagues? 12 marks for question 3.
Thank you very much, Mezapi. Colleagues, question 3, inputs, subtractions, additions, anything that you need now to say there on question 3. Let me maybe open up for questions or inputs. Anyone? I don't see any hands, Mezapi. It basically says now colleagues are happy with everything in question 3. But there at 3.2, the scale, yes, is given. So it basically says now the colleagues must actually now use a ruler to actually confirm that now learners used the correct scale instead of just drawing the vectors, because it basically says now accept the labels 3 meters is equals to 3 centimeter north. That is only when we can be able to give a mark. 300 meters 3 centimeters now east, that is only when we can give a mark. So it basically says you will need somehow a way of having now your ruler, because the expectation is this learners must use a ruler and be able now to convert now the scale into the desired now answers. Mehlaba, inputs please.
Nambane is Meswigele.
Okay, Meswigele.
Nambane, I wanted to ask Me about the scale. She said for the angle it's 80 degrees to 100.
The angle
98.
98 to 100. Yes.
98 to 100.
Okay, thank you.
Yes, that is now a
The range.
bullet number 4 for the range of the angle.
Okay, thank you.
Thank you very much. Now that you are saying you are with Mehlaba Mesugeleng, for the register, each and every particular person, maybe if you are watching as 3 teachers from the same school or 2 teachers from the same school, each one of you must complete now the register, colleagues. Thank you very much. Mezapi, let's go to question 4.
Thank you, Ntate Nambane. Question 4 was saying 2 vehicles Q and R are approaching a traffic light intersection at 20 meters per second. The light turns orange when they are 30 meters from the intersection. The driver in vehicle Q immediately hits on the brakes and slows down to a stop at the intersection. The driver in vehicle R accelerates at 4 meters per second squared through the intersection for 3 seconds before continuing at a constant velocity. 4.1 was saying define the term velocity in words. Velocity is the rate of change in displacement. 2 marks for that. And 4.2.
Askisi Mezapi, kindly move your memo up. Thank you very much.
Thank you, Ntate Nambane.
Thank you, Mezapi.
Velocity is the rate of change in displacement. 2 marks for that. And then convert 20 meters per second to kilometers per hour. It will be 20 divided by 1,000, which will be divided by 1/60 multiplied by 60. That will give you 62 kilometers per hour. If Elena here, like in the previous one, had written 20 divided by 1,000 equals to 1 divided by 3,600 equals to 72 kilometers per hour, then you are going to award the 3 marks as they are. And like we said in the previous, in question 2, if the learner did not write the SI unit for 72 in kilometers per hour, because the question had said 2 kilometers per hour, if the learner had just written 72, that simply means we are going to give for consistency's sake. And 4.3, calculate the time taken by the vehicle Q to reach the intersection. Velocity equals to displacement over time, which will be 20 equals to 30 over t, or time. The time will be 1.5 seconds. Except if they have used any formula of the speed. And then question 4.4 was saying calculate the final velocity reached by vehicle R in 3 seconds. Acceleration equals to change in velocity over time. 4 equals to final velocity minus initial velocity, which is 20 divided by 3. The final velocity will be equaling to 32 meters per second. 1 mark for the formula acceleration equals to change in velocity over the time. 1 mark for substituting 4. 1 mark for substituting on the right side the whole thing. They might write VF for final velocity, VF minus 20 divided by 3, and then VF equals to 32 meters per second, the final mark. 4 marks for question 4. any questions? Colleagues, 12 marks for question 4.
Any questions, colleagues? Inputs regarding question 4. It seems like we don't have any inputs, Zapi. Then it basically says colleagues are happy with that. I also do not have anything here. But for 4.3, you did say we
Yes.
can accept any equation, even if it's not written in words but symbols.
Yes.
And you can also do the same for acceleration is equals to now changing v over changing t.
Yes, sir.
Thank you very much. So colleagues, we can also accept now for purpose of emphasis the equations that are used now in not necessarily in words, but when a learner has used formulas. Mebusi Manchu. Mebusi.
Good morning, colleagues.
Good morning,
good morning,
ma'am.
colleagues. I hope you can. I hope you can hear me.
100% Mebusi.
Colleagues, I would just want to go back to 4.2. Ne? When I just want to sensitize colleagues that when they mark, they need to ensure that the learners wrote the correct thing. For example, if you see that the answer is correct, then chances are such that a learner has substituted correctly. Because in 4.2, for example, the learner can say 4 divided by 1,000 multiplied by 3,600. Because when you divide the whole thing by 1 over 60 times 60, it's the same as multiplying by 4,600, colleagues. So let's not, when we don't see the substitution exactly as it is on the memo, then we might think that something is wrong. Let's just ensure that when you see the answer is correct, then go back to the substitutions just to check whether the learner did the correct mathematics or not. And also, if the learner did something incorrectly in terms of mathematics, but the answer is correct, it does not automatically mean everything is correct. So it is important to check the substitution that is correct before concluding that everything is correct. So it goes both ways. So if there's an error in substitution, even if the answer is correct, you don't give the mark for the final answer because there was an error in the substitution. I'm just doing this for the sake of probably new teachers. We just don't mark a correct answer if there was an error in substitution. Then automatically we don't give the mark for the final answer. Mezapi, don't forget that there are teachers who might be new, so let's try to bring them on board in terms of how we mark as well and where we put them the ticks. Thank you, colleagues.
Thank you very much, Mebusi. Your inputs are always valuable. Ndlalankulu, you can open your mic for inputs.
Good morning.
Good morning, sir.
Thank you so much. I just have a question on question 4.2. Sorry.
4.2.
4.2. In terms of converting the speed, the speed from meters per second to kilometers per hour, right? From answer series, the conversion unit from meters per second, we normally divide by 3,6. So instead of writing the whole conversion unit as dividing the speed by 1,000, and then again divide the speed by 1 over 60 multiplied by 60, if the learner has used that conversion unit from multiplying by 3,6, yes, can we award the learner a mark?
Thank you very much. It is a common way of quickly converting, Let's hear from Mezapi. Maybe show question 4.2 also on the screen. Instead of doing the complicated science of 60 multiplied by 60 and dividing by 1000, it gives you 3,6, and then eventually you get the correct answer. So the learner did not show the 1000, did not show the 60 multiplied by 60, but they have now that division factor of 3,6.
Yeah.
Okay,
And
Mezat.
as Mebusi has already alluded to that, to say if the learner maybe has used that method but gets the very same answer, then you'll go back to your calculator and type in those numbers and see if it gives you the correct answer. Then it is acceptable and the 3 marks will be awarded for the learner.
Mebusi, kindly come in.
Did I hear you correct, Osbus?
Mebusi, kindly come in as I am also digesting it, because I think the question basically wanted to check if now they understand the basic conversions of meter to kilometer, yes, meter to kilometer, and now seconds to hours. Maybe that's the reason why the emphasis was on the 1000 and the 60 multiplied by 60. But now let's quickly now check with Busi. But for me, I think, colleagues, we can only award 1 mark for the final answer of 72. But it's something that we'll need now to agree upon, because the thinking is, if it's 3 marks, we cannot award 3 marks basically for just saying now 20 divided by 3,6. Where does the 3,6 come from? So we are creating a misconception, a common error from this particular learners. We understand the 3,6, it's basically an easier way of converting, because it's a factor that we normally use, or that the books have now intended on using. But the thinking should be, colleagues, we want to see them understanding to convert from meter to kilometer, hence the 1000. We want now to understand the conversion from seconds now to an hour. That's the reason why we need to allocate a mark for 1000, allocate a mark for 60 multiplied by 60, and the final answer thereof. So if they used the 3,6 Mezapi, the thinking should be, let's penalize them, because that is not the right way of doing it. If it was 1 mark, it will mean the intention was only to see the correct answer. So in this instance, it's 3 marks, so we cannot award for the 3,6. So I'm just putting it out there, just that the intention here, colleagues, was also to emphasize issues of conversion as part of the curriculum of now grade 10 technical sciences. So I am going to give you Ntate Dlalankulu for the inputs, because I see your hand is up. Mezapi, also you can come in, but the thinking is, let's penalize the learners who used now the 3,6, but only getting the answer of the 72 kilometers per hour. Mr. Dlalankulu.
No, I'm sorted. It's just that I didn't turn off my hand signal.
Okay, but do you understand the reasoning behind why we cannot award for the 3,6 only?
Yes, everything is fine.
Thank you very much, sir. Mezapi, inputs, please, and then we can close the issue of 4,2 or 4.2. Sorry.
Nambane, thank you very much.
Thank you very much. So, colleagues, at 4.2, let's not accept the 3,6. Mebusi comes in and continue, Mebusi.
Okay, colleagues. I fully agree that, remember, colleagues, this is grade 10, and we want learners to know how to convert for now and for the future. So we have an ATP that has given us a lot of time to teach learners how to convert from one unit to another. So the most important part here, we wanted to check learners are able to convert from meters to kilometers, that's number one. Then from seconds to hours, that's the second one. But now, since they've used 3.6, which does not show those two conversions, but the 3.6 is correct. It's just that it is just the quick way of saying, okay, 60 times 60 is 3,600, and we are still going to divide by 1,000. Then let's give it will give us 3.6. So because 3.6 is correct, let's give the mark for the 3.6 and the mark for the final answer. Let's penalize 1 mark for not showing how they got the 3.6. So let them get 2 out of 3. But colleagues, please, when you go back to your learners, tell them they need to show all the conversions. In this case, there's 2 conversions, so we want to see both the conversions. If there's 1 conversion, we still need to see 1 conversion. So it is important for them to show all the conversions because marks are awarded for all the substitutions. But the 3.6 is actually correct. It's just that it is a quicker way of getting it. It does not show the conversions. So let's give the times 3.6 and the final answer, but let's penalize 1 mark. They shouldn't get full marks. Thank you.
Thank you very much, Mevusi. But the thinking is we wanted now to assess our learners in terms of how to convert. So we'll penalize only 1 mark, as you are saying. So for the use of 3.6, it will be 2/3. Thank you very much for all the inputs, colleagues. Mezapi, we can go to question 5.
Thank you, Mtate Nambane. Thank you, Osbusi. Thank you, Mr. Ndlalankulu. Question 5 was saying, define the term normal force in weights. The normal force is defined as the perpendicular force exerted by a surface on an object that lies on that surface. So it is 2 marks. 1 mark for the normal force is the perpendicular force exerted, 1 mark up to force exerted by the surface on the object. The second mark that lies on the surface. And then 5.2 says a block of 9 kg rests on the surface. 5.2.1 identify the non-contact force exerted on the block. The answer for 5.2.1 is the gravitational force. And 5.2.2 says W equals to mg, which equals to 9 multiplied by 9.8. That will give you 88.2 newtons. That is 3 marks. 1 mark for the formula, 1 mark for the substitution, and the last mark for the final answer. 5.3 was saying a block is pulled to the right by a constant force of 7 newtons. It experiences a frictional force of 3 newtons as shown below. 5.3.1 says define the term frictional force in weights. The frictional force is defined as the force parallel to the surface that opposes the motion of an object and acts in the direction opposite to the motion of the object. The first mark for the force that acts parallel to the surface. The second mark that possesses the motion of the object and acts in the direction opposite to the motion of the object. the second mark. 5.3.2 was saying, draw the free body diagram of only the contact forces acting on the object. It will be the normal force going upwards with the vector and the arrow and the label, and the applied force to the right, or 7 newtons force, as well as the frictional force, or FF, of the learner might write small letter f, or 3 newtons of frictional force as it is. We are going to award the marks as follows. The arrow plus the label 1 mark. Ignore comparative lengths of arrows. Penalize 1 mark for an extra force that will be drawn, and penalize 1 mark if vectors do not touch the dot. It is 3 marks for 5.3.2. 5.3.3 was saying which 2 forces are at equilibrium: the normal force and the gravitational force. 1 mark for the normal force, 1 mark for the gravitational force. And 5.3.4, calculate the resultant of the forces acting on the box. FR equals to F applied plus frictional force, which is 7 plus -3, that is going to give you 4 newtons to the right. 1 mark for the formula, 1 mark for the substitution of 7 plus -3, and 1 mark for 4 newtons, and 1 mark for the direction to the right. That is 17 marks for question 5. Any questions, colleagues?
Any questions, colleagues? Inputs? Anything in question 5? It seems like everything is okay. Maybe Mezapi, explain bullet number 3 on 5.3, maybe to support and assist our newly appointed teachers. Penalize 1 mark if sorry, not that one, number 3, which is now penalize 1 mark for an extra force.
Okay. If in case 4 forces are drawn on the sketch, therefore you're going to penalize 1 mark. You'll give let's say the learner had written the normal force, the applied force, and the frictional force, and the gravitational force. You can take either one of these 3 bullets to give a learner 2 out of 3.
Out of 3. Thank you very much. So it basically says if there's an extra force, it will only be a maximum of 2 over 3.
2. Yes.
Thank you very much, Mezapi. Colleagues, any inputs? If there are no inputs, just as a quick reminder, I have also sent now the link to the register. Kindly complete that. I see there's about now 17 people here, but on the register I have 4, so please do not forget now to complete the register. Mehlaba and Mesoigeleng.
Ntate Nambane, there by 5.3.4.
5.3.4, yes.
Yes, I just want to be sure. There where it says resultant force is equals to F applied plus F. I've taught them in class that resultant is F1 plus F2, like the number of forces. So can I award a mark for them saying F1 plus F2 to represent applied force and frictional force?
Mezapi?
F1 plus F2.
Yes, ma'am.
F1 plus F2.
Yeah,
Yes.
Instead of basically saying F applied and frictional force F1 plus F2. Yeah, I think we can accept.
Okay, thank you.
Yeah, we can accept. But for future, let's allow them to identify the actual forces that are going to
Alright.
contribute into the resultant force, because now if you say F1 F2, it doesn't necessarily represent which force is actually the one contributing to the F net or the resultant force. Because remember, when we move to grade 11, when we move to grade 12, and now dealing specifically with the application of Newton's second law, it is always advisable for them to specify which forces are actually contributing to the F net. So in the near future, let's just ensure that now they specify basically which forces are contributing to the F resultant or F net. Thank you very much. Mezapi, I don't see any other hands. We can basically go to question 6. There's Mebusi. Mebusi, inputs, please.
Colleagues 5 through 2. I'm not sure whether Mezapi, because I have connectivity problems. Mezapi, I'm not sure whether you actually clearly said to the colleagues that the mark is for the arrow, both the arrow and the label. In other words, if the arrow direction is correct but the label is incorrect, we don't award a mark. And the other way around, colleagues. Next. Please let us ensure that we do so. In other words, for example, the one to the left, if we see a capital letter F to the left, that is incorrect, because capital letter F we use for the applied force, but we use the small letter F for friction. So let us ensure that one mark is for the correct direction of the arrow and the label. If one of them is incorrect, then we penalize. Remember, colleagues, I said I'm doing for the benefit of new teachers, so that we can mark correctly. Thank you, colleagues.
Thank you very much, Mebusi. Any words, Mezapi, on question 5 before we move?
Nothing, Dr. Nambane.
Thank you very much, Mewaka. Then let's kindly move to question. Mebusi, is it an old hand? Oh, thank you very much. Let's move now to question 6.
Question 6 was saying a motor mechanic uses 2 spanners to tighten a bolt. The mechanic applies a force of 25 newtons. The distance between the center of the bolt and the point of application of the force is 22 centimeters for one spanner and 17 centimeters for the other spanner. In each case, the angle between the applied force and the spanner's handle is 90 degrees, as indicated in the 2 diagrams. 6.1.1 was saying define the term torque in weights. Torque is said to be the turning force of the force about the point. That is 2 marks for 6.1.1. 6.1.2 was saying determine with the aid of the of a calculation which spanner produces the greater torque. Express the torque in basic SI units. And we're going to start first by converting centimeters to meters. We convert 22 centimeters to meters, which give us 0.22. The number
Yes, Mezapi.
You've forgotten to tell me to go up a bit. Thank you.
I was about to
And
actually take it down a little bit.
okay, down.
Down. Thank you.
And then 17 centimeters equals to 0.17 meters. And therefore, the Turkey for the spanner A will be equaling to the force multiplied by the perpendicular distance, which equals to 25 multiplied by 0.22. That gives us 5.5 newtons meter. And the Turkey for spanner B equals to the force multiplied by the perpendicular distance, which is 25, multiplied by 0.17. That gives us 4.25 newtons meter. How do we mark? We mark 1 mark for the conversion, for both conversions of 22 centimeters and 17 centimeters to 0.22 meters and 0.17 meters. 1 mark for the formula for each of the formulas, either for A or B. 1 mark for the substitution of A. If the learner had substituted 25 multiplied by 0.22 and 1 mark for the substitution of 25 multiplied by 0.17 and 1 mark for both 5.5 Newton meter and 4.25 Newton meter. Let us have a look at the marking criteria. Correct conversion from centimeter to meter for both will be 1 mark, and then the formula will be 1 mark. The substitution for the calculation of 1, the substitution for the calculation of 2 is another 1 mark, and then 1 mark if any of the answers is correct. And then the last mark will be for if the learner says spanner A will produce the most Turkey, then the last, that is where the last mark is allocated. It is 6 marks for that. And then 6.1.3 was saying the mechanic uses another spanner to loosen a nut. This time a take of 900 Newton meter is required. Calculate the length of the spanner if she applies a force of 160 newtons perpendicular to the length of the instrument. The Turkey equals to force multiplied by perpendicular distance. No mark for the formula. 900 equals to 160 multiplied by the perpendicular distance. Perpendicular distance will be equaling to 5.63 meters. It is only 2 marks. So 1 mark for the whole substitution, and the last mark for the final answer with the SI unit. 6.2. A 32 newtons force acting at 55 centimeters from the pivot is balanced by an unknown force W, which is acting at 0.3 meters from the pivot. Ignore the mass of the ruler. 6.2.1 is saying, state the law of moments in weights. The law of moment states as follows. The law of moment says that for a body in equilibrium, the sum of the clockwise movement about the point must be equal to the sum of the anti-clockwise movement about the point. 2 marks for that. 6.2.2. What are the 2 conditions for equilibrium? it will be the sum of the clockwise movement above the point must be equal to the sum of the anti-clockwise movement about the point, and the resultant force will be equaling to 0. 1 mark for this, the statement that the sum of the clockwise movement about the point must be equal to the sum of the anti-clockwise movement about the same point, and 1 mark for the F frictional force equals resultant force equals to 0. 2 marks for 6.2.2. 623. Calculate the magnitude of W. It will be the sum of the TQ equals to the sum of the TQ before equals to sum of the TQ after, which equals to 0.5 multiplied by 0.3 multiplied by W equals to 35 multiplied by 0.55. W will be equaling to 58.67 newtons. 1 mark for the formula, 1 mark for the substitution on the left, 1 mark for the substitution on the right, and 1 mark for the final answer with the SI unit. 18 marks for question 6.
Thank you very much, Mezapi. Inputs, colleagues, on question 6. Meso Ikheleng Mehlaba.
There by 6.2.
There's a very bad noise. Askisi Mehlaba. There's a very bad
6.1.2.
Okay, 6.1.2. You are now better.
Okay. Can we please scroll up the marking criteria?
Thank you.
Thank you. There where it says correct conversion from centimeter to meters. I see there by the calculation they showed from 17 centimeters 0.17, but the scripts that I marked they didn't show, but there by substitution they did write 0.22 and 0.17. So can I just award 1 mark when I see in both calculations the 0.22 and 0.17?
They did not show where it says conversion of 17 centimeter to 0.17.
Yeah, they didn't show their conversion.
You only see the 0.17 and the 0.22 in the substitution of the form in the formula after the substitution.
Yes.
Okay, let me give it to Mebusi and Mezapi. That mark of thank you, Mehlaba. I don't know what happened to your mic, but it's quite now disturbing.
It is still.
Yes, Mehlaba, you are saying?
Then another question there by 6.2.3.
6.2.3.
The equation. Yes, they use that notation, but in class we've taught them the one for M clockwise is equals to M anti-clockwise. So it's for future reference. Should we use this one or should we continue using MCW is equals to MACW?
Noted, Mehlaba. Let's start with this one of the conversion 612 Mezapi. If the learners did this 1 mark here of conversion, the teacher only sees the 0.17 after the substitution and the 0.22 after the substitution. Can we award now 2 marks for saying 0.22 together with the substitution? Because definitely it means now that learner did convert somewhere So I'm not sure if how best can you go about it. We'll need now the inputs of Mebusi and your expertise also, Mezapi. Because now the learner did not indicate it separately, but within the calculation you can see that the conversion was made.
I'll give to Ausbusi to respond first.
Okay, Ausbusi.
Thank you, colleague. Remember, in 612, we just said to the learners, it's 612, ne?
Yes.
We just said to the learners, determine with the aid of a calculation which span of measures is greater to. We did not say, learners, before you do your calculations, show your conversions. But in the substitutions, learners know that their substitutions must be in meters. So as long as they've converted to meters when they substitute, then they are correct. So if you see the 0.22 there for the A and the 0.17 there for the B, then you will give the conversion mark there. So the learner will still get full marks. We did not say they must show the conversions before they calculate. So as long as they, in their substitutions, they substituted in meters, and we can see the 0.22 and the 0.17. For both the 0.22 and the 0.17 that we see, we give 1 mark for the conversion, and then we'll give the other marks as it is set in the marking criteria. So that learner will still get all those marks, and if he has concluded, then we'll get full marks. So I hope that is correct.
Very clear.
I mean, that is clear.
That is clear. Thank you. Thank you very much, Mebusi. Then maybe go to
623.
623, please.
Colleagues, it is important that learners relate the law and the calculation based on the law. In 622, clearly we say they should state it. Then the learner clearly says the sum of the clockwise moment. The word sum is very important. So even if they write it in full, they need to say maybe sum of m clockwise equals sum of m anti-clockwise, or total clockwise moments equals total. As long as there's an indication of sum or total, then we know, the learners know what is going on. But just say clockwise moment equals anti-clockwise moment is not good enough. The word sum is very important. So even if they write it in words, it must still say sum, not just m. Thank you, colleagues.
Thank you very much. Is it a follow-up hand, Zapi? I think Mebusi explained it in detail.
Did I raise my hand?
No, you did not. You said you'll comment after Mebusi, but I think Mebusi is very clear in terms of 612 and 623. Mehlaba, is it an old hand or it's another input? And Mesuichele?
I am not sure if I'm the one who did not follow, but I was asking about 6.23, the notation that they gave there as a formula.
Yes,
not
what? Okay.
Not the definition. So
yes.
I was asking
no,
if in future we should use this one, or I think I didn't follow.
All right, let me explain. Mebusi was using the definition or the law in terms of explaining 623, because it says now the sum of clockwise moments equals to the sum of anti-clockwise moments. So if the learners are going to use any other conventional statements to calculate for W at 623, it should be now an indication of the application of the law itself, which says now the sum of clockwise moments. They cannot necessarily just say clockwise moments. It must be the sum of clockwise movement is equals to the sum of anti-clockwise movement. But to answer you in short, it is always advisable to say let's encourage them to use now this notation moving forward, such that we have now a consistent system of how to write now the principles and the laws that basically says the sum of anti-clockwise clockwise movements will be equals to the sum of clockwise movements. So for reference and for now, just now check if your learners did indicate it's actually the sum of clockwise movements equals to the sum of anti-clockwise movements. Thank you very much, Mehlaba. And
Dr. Nambane,
yes, me.
on that one, I understand.
Mm,
Now, I've taught them that when they substitute, for example, 0.3 times W, it's our clockwise moment. So I've taught them that they must substitute correctly. I must see that now they substituted on clockwise and the other one is substituted anti-clockwise movement. So now, as Kisne, for me, I'm not familiar with this. That's why I want to understand clearly. So if we use this notation, how would I know that the learner understands that they're substituting 0.3 times W as their clockwise moment? I don't know if I'm making sense.
But the values thereof should basically be the ones informing you. The 0.3, the 0.55 should be the one informing you that now this is for anti-clockwise and this is for clockwise. Because remember, the notation basically just say the sum of total moments is equals to the sum of total moments of anti-clockwise. So other learners, what they will do is they'll rather take the 32 multiply by 0.5 on the left hand side and now have the 0.3 on the right hand side. So the substitution thereof is what will be an indication which ones are the clockwise movements and which ones are the anti-clockwise movements. I've seen other books also and teachers also saying the sum of torque A for anti-clockwise and then is equals to the sum of torque C for clockwise, just to make it easy maybe for one to understand. But the principle is we cannot necessarily write it in words to say the sum of clockwise movement is equals to the sum of anti-clockwise movement. We need now to use symbols that represents the actual notation. Happy Mehlaba.
Thank you, Dr. Nambane.
Thank you very much. Peme Matli. Noted Mebusi.
Good morning, colleagues.
Good morning.
Colleagues, I am at 6.1.2.
Okay.
My question is, what if anyhow the learner got the wrong answers for both talks? Then, fortunately, the learner says spanner A produces the most torque. I just want to know if we give a mark for that spanner A, even if the answers are incorrect. They might be incorrect in the case of maybe the conversion. And then, but the learner was able to see that the spanner A produces the most torque. So do we give a mark for saying spanner A?
Thank you very much. Nicely said. Mezapi Mebusi, your hand was up. Mebusi.
Okay, colleagues, let us go back to 6, the one of the calculation, 623. Ne?
Okay.
623, it is okay if they start with a statement in words. For example, sum of clockwise moments equals sum of anti-clockwise moments. It's okay, because the symbol, when we go to the symbol, ensure that they write the correct symbol, not an E, because that's what we have a problem with most of them when we mark, even with physics. So if they use the symbol sum, it must be the correct symbol, not an E. So if you are afraid that your learners will not use the symbol, the correct symbol, it's fine to use the words. But the most important thing that I was saying, the word sum or total must be there to indicate that we are applying the law. The learners must be able to relate the stating of the law and the application of the law. They go hand in hand. They are not two separate things. So it's okay if they write some clockwise moments equals some anti-clockwise moments in words. It's fine. But the word sum is very important because it's the application of a law. Now, I don't know whether I can go already to the
612.
one of 612 or Mesapi. Do you want to take it?
No, you can take it, Osbusi.
Colleagues, in 612, the reason for marking criteria is we mark everything, we try to give learners a benefit. So as long as at the end the conclusion is there, spanner A produces the most work, it's fine. Because they might have had problems with conversions and whatever. And even if there's no calculation at all, some of the learner would just say spanner A produces the most work. It's fine. We don't have negative marking between the calculation and the conclusion. So as long as the conclusion is there, for spanner A produces most work, the learner should get 1 mark for that. Then the other marks are on the calculation. So it's okay even if there was an error, but the correct conclusion is there. The learner will get the mark for the correct conclusion. Thank you, colleagues.
Thank you very much, Mebusi. Thank you very much, Mezapi. Thank you very much, Mephem, for the inputs and everybody else. There's a hand from Mahotso Mutibedi. Mahotso?
Good morning. Yes, can you hear me?
Yes, we can hear you clearly, Me.
On the textbook, Sasol textbook, Technical Science Grade 10, on page 119, the notation that teach with is this one. MCW equals to MACW. I think, I'm not sure if I'm correct, Nesaba was asking in terms of teaching, for us new teachers. Do we now use the symbol sum, or do you continue using it as how they noted it on that book? Because kids tend to be confused if I just say sum T is equal to sum tau again on the other side. I must indicate which one is clockwise and which one is anti-clockwise. And even with substitution, if they are substituting and they don't know where they are taking their clockwise and where they are taking their anti-clockwise, and they're just substituting like you have there on the answer, then it starts confusing them again. So which one do you use? Do you use the symbol sum, tau, or do you use MCW and MACW like in the textbook for Technical Science Grade 10?
Noted, Mahotso, thank you very much. That is now for 623. 623. Mebusi, I want to chip in, but I think you did explain that whichever way it's acceptable, provided that now the law itself and the application basically support each other. So if we see that there's a sum of MCW and MAW, then I believe also we can be able to accept. But for future reference, I think now it will be advisable if we can stick now to the notation that is on the memo as a guideline for us to move forward. So Mebusi, maybe you can wrap it up to assist and help Memo Chibedi and other colleagues, because now the reference is the textbook against the actual law. So learners are exposed to textbooks and teachers are using the textbook. So maybe we need to have a common understanding of exactly how best can we approach it in a sense of now our calculations as a set of grade 10 teachers.
Okay, colleagues. Can we go back to our preparations? When you prepare, it is important to consult the ATP and the examination guideline. So the ATP and the examination guidelines are the ones that are guiding you on what to prepare and how to teach, not the textbook. So we don't teach according to the textbook. We teach according to the ATP. So when you go to the ATP, it says, for a body in equilibrium, the sum of clockwise moments about the point must be equal to the sum of anti-clockwise moments about the same point. So what we are saying is, whether you say it in words, you teach your learners to write it in words, or you teach them to use the symbol, it does not matter. But when you teach, show your learners that you are applying the law. So in their calculation, they are using the law to do calculations. So when they start, they just say sum and clockwise moments equals some anti-clockwise moment. Even if it's in words, it's fine. But the word sum is important. So they just need to say sum. So it doesn't really necessarily have to be a symbol, because sometimes a symbol becomes a problem, because when they use a symbol, they use an E instead of the symbol of sum. So what we are just saying to you is include the word sum, just to show the learner the relationship between the law and the application of the law, which is the calculation. So don't change how you were saying. It's fine to say sum of anti-clockwise moments equals sum of anti-clockwise moments, or you show it with the arrows that goes clockwise and anti-clockwise, but sum must be there. Thank you, colleagues.
Thank you very much, Mebusi. Colleagues, I think we have exhausted the discussion on question 6. Let's allow Mezapi now to go into question 7. If you have questions, I'm trying to answer them in the chat as well. Colleagues, I must say, I only have 6 people who completed the attendance register. Kindly complete the attendance register, because once this meeting ends, you will not be able to access the link anymore. So I'm sending it again to the chat. Kindly complete. You just need now to use your phone to do that. Kindly complete the attendance register, because in this meeting there's about 19 people, but we cannot be necessarily having only 6 people who completed now the register. And it's basically Ansi, Mekeke, Ozil Silele, Mebusi, myself, and Nsidi. So colleagues, basically now complete the attendance register, please. You can continue, Mezapi. Thank you very much.
Tate Nambane, before I continue, did you also send the link to the group, to the WhatsApp group, technical science?
The attendance register?
Yes.
Not yet, Mezapi.
Okay.
Yes, when I will send it to you separately. Just continue with the presentation.
Thank you very much. Question 7. Thank you very much, colleagues, for all the inputs and all the clarities from Tate Nambane and Memanchu. 7.1 says, define the term gravitational potential energy for 2 marks. The gravitational potential energy is the energy that the object has because of its position from the surface of the Earth. 2 marks for that. 7.2 was saying, an object of mass 0.9 kilograms rests on a height h above the ground. It then falls freely until it reaches the ground. The mechanical energy of the object at the height h is 3.5 joules. Ignore the effects of friction. 7.2.1 says, calculate the height h from which the object falls. ME at the top equals to EP plus EK, which is equaling to 3.5 equals to MGH plus 0. 3.5 equals to 0.9 multiplied by 9.8 multiplied by H. Our H equals to 0.40 meters. 1 mark for the formula mechanical energy equals to EP plus EK. 1 mark for substituting 3.5 and 1 mark for the substitution on the right hand side of 0.9 multiplied by 9.8 multiplied by the height, and the final mark for the final answer with the SI unit, which is 0.40 meters. 7.2.2 was saying, calculate the kinetic energy of the object when it has fallen to a height of 0.2 meters below the ground, on the ground. EP equals to 0, EP multiplied by 0.2 meters equals to MGH. 1 mark for that, which is equaling to 0.9 multiplied by 9.8 times 0.2, 1 mark. And no mark for the answer of 1.764. And another mark is for EK at 0.2, which equals to 3.5 minus 1.764, which equals to 1.736 joules. 4 marks for that. The first mark is for EP at 0. EP at 0.2 meters equals to MGH, first mark. The second mark is for the substitution of MGH, which is 0.9 multiplied by 9.8 multiplied by 0.2, which equals to 1.764. The third mark is for EK at 0.2 equals to 3.5 minus 1.764, which equals to 1.736, which is the final mark. And 7.2.3 was saying, calculate the speed with which it strikes the ground. ME at the bottom equals to EP plus EK. 3.5 equals to 0 plus half multiplied by M multiplied by V squared. 3.5, 1 mark for 3.5 equals to 1 over 2 multiplied by 0.9 multiplied by V squared. The final mark will be for V, which is equaling to 1.96 meters per second. That is 3 marks. The first mark for 3.5, for substituting 3.5. The second mark for substituting half multiplied by 0.9 multiplied by V squared. And the last mark for saying V equals to 1.96 meters per second. Question 7, 13 marks. Any questions, colleagues? Any inputs? 7.2.2, I see here on the memo, the 9.8 is written as 98. Just put a comma there, colleagues. I think that is the only thing that I see. Any questions? Any inputs?
Thank you very much, Mezapi, for question 7. I don't see any hands or comments in the chat. It basically says now colleagues are happy with question 7. I also believe it's as straightforward as it is, so maybe it will be advisable, Zapi, to go to question 8.
Question 8. It reads as follows. A learner receives the following materials during a practical investigation: a copper wire, a carbon paper, a magnesium strip. The materials are of the same dimension. The aim of the practical investigation is to investigate the electrical conductivity of the materials. 8.1
Just move the
says
memo.
right.
Just move the memo, Mezapi.
Nambane.
Thank you.
8.1.1 says write down the dependent variable. The dependent variable here is electrical conductivity, and 2 marks for that. The independent variable for 8.1.2, which is the copper wire, the carbon paper, and the magnesium strip. 8.2 says formulate the investigative question for this investigation. Which of the 3 materials is a good conductor of electricity? Or what is the relationship between the copper wire, carbon paper, magnesium strap, and the electrical conductivity? The marking criteria will be for you to write, the learner to write the dependent and the independent variable correctly. And then the second one will be for the question about the relationship between the independent variable and the dependent variable. The note says, if the question can be answered with a yes or a no, award 1 mark only for the correct variables. And then 8.3 was saying formulate the hypothesis for this investigation. The hypothesis was to say carbon wire or copper wire or carbon paper or the magnesium or magnesium strip is a good conductor of electricity. And the marking criteria will be stating the dependent and the independent variable, and the statement about the relationship between the dependent and the independent variable. You will award 2 marks. 8.4, list the other 4 apparatus except the ones listed above that the learner will have to use. It is a battery or cells, the bulb, the ammeter, the connecting wire, or the crocodile clips. Any 4 of those given. Total mark, it is 12 marks for question 8. Any questions, any inputs, colleagues?
There's a hand from Mahotso Mutibedi. Kindly open up your mic, Mutibedi. Noted, Isaac.
For independent variables, if they say type of material, do you give them a mark or should it be listed like that?
812.
Yes.
Okay. Mezapi, the learner did not say copper or carbon paper and magnesium. They just said type of material.
Type of material.
Yes, instead of specifying copper, carbon paper, and magnesium strip. Eight one two.
I'm thinking about it in the Nambane.
Yes, me.
The learner might have taken the type of material from the underneath the three materials which are given, or from above there it is written the materials. So the learner might have taken it from there. Will I be too lenient if I say we give for the type of material? What do other colleagues think?
Input colleagues on 812. This one is open now for the floor. If the learner did not specify copper, carbon paper, and magnesium, just said types of material or types of material. While we think of it, let me give Ndate Isaac a platform also to say something. We have noted 812. Ndate Isaac.
Oh yeah, no, sorry. I was on that as well, and the other one was that if the learner indicated only two materials, what can we maybe be lenient also there?
The learner just said copper and carbon, and then magnesium strip is not there, or carbon and magnesium. So there's one missing, but the learner basically identified that it's material also. Noted also that Isaac, thank you very much for the input. Mehlaba and Mesuicheling. Yes, me.
Also on that question,
812.
Yes, the aim of the practical says to investigate electrical conductivity of materials. We have taught the learners that on our aim we find our independent and dependent variable, and we said that we have electrical conductivity. Now I said that if they said materials, I wanted to ask the same question. They said the electrical conductivity of, they didn't say of copper, carbon, and magnesium strip. They said of materials.
Okay. No, noted. So it's basically the same thing as Mutibedi. Thank you very much. We'll look into it. Mezapi, are you wrapping it up?
Could I please ask Ausbusi Ausbusi, are you still in here to intervene?
Mezapi, I'm in, even though I'm between physical sciences and technical sciences.
Sorry.
But I'm in. Colleagues, it's okay. Let's accept type of material or just materials.
Yeah,
it's fine.
It's fine.
But if the learner wants to specify the materials, then it is important to specify all of them, because it is written, it is copper. Then obviously, then you will change to carbon paper, and then you will change to magnesium strip. So learners must understand that when we say independent variable, it's what we are changing. So we are changing from copper to carbon to magnesium strip. So once they decide to mention the materials, unfortunately, they have to mention all. Otherwise, if we accept two of them, it's as if we are just changing between two materials. So they can either say materials, it's fine, or type of material, it's fine. But when now they mention those materials, it must be all of them. Thank you, colleagues.
Thank you very much. That answers now the question of Ndati Moki to say now If they specify, all of them must be there, so it's now either 2 or 0. And Memo Hlaba, Memo Tivedi, Mesegeleng, then types of material, it's accepted. I'm not sure if these hands are now old hands or new hands, and the Demoki and Mehlaba and Mesegeleng. Looks like it's
Oh no, it's an old hand. Sorry.
Thank you. It looks like it's an old hand. May we can go now to question 9.
Okay, let us go to question 9. Thank you very much, colleagues. Question 9 was saying, the first one, 9.1 says, define the term compound in words. A compound is a substance made up of 2 or more elements in the exact ratio 2 marks. 9.2 says, answer questions 9.2.1 to 9.2.5 by choosing from the list below. Write only the letters A to G next to the question number to 9.2.1 to 9.2.5. 9.2.1 was saying write down the letter of 2 elements. The 2 elements will be A and C. The 9.2.2, 2 compounds, it will be D and F. 9.2.3, write down the letters of 2 anions. It will be E and G. 9.2.4, a cation will be B. And 9.2.5, write down any 3 pure substances, A, C, D, O, and F. So if a letter had written A, C, D, you give 3 marks. A, C, D, F, 3 marks. C, D, F, 3 marks. D, F, A, 3 marks. Any of the 3 of the 4 given. 9.3 was saying write down the chemical formula of the following compounds. Lithium nitrate, it is LiNO3. 1 mark for Li, 1 mark for NO3. Bromine chloride, it is BrCl. Capital letter B, small letter R, capital letter C, small letter L. 1 mark for Br and 1 mark for Cl. 9.3.3, ammonium sulfate, it will be open bracket NH4 close bracket 2, 1 mark, SO4, 1 mark. 9.4, write down the name of the following compounds. AlCl3, it is aluminium chloride, 2 marks, 1 mark for aluminium, 1 mark for chloride. 9.4.2 K3N, it is potassium nitride, 1 mark for potassium, 1 mark for nitride. And Na2CO3, it is sodium carbonate, 1 mark for sodium, 1 mark for carbonate. 9.4.4, Mg open bracket OH close bracket 2 magnesium oxide, 1 mark for magnesium and 1 mark for hydroxide. And then 9.5 was saying the balanced chemical equations of the following. Write down the balanced chemical equations of the following. It is 2Zn 9.5.1, it is zinc plus oxygen to give you zinc oxide, which is 2Zn plus O2, 1 mark. gives 2 ZNO and 1 mark for the balancing, 1 mark for the reactant, 1 mark for the product, and 1 mark for the balanced equation. And 9.5.2, sodium hydrogen carbonate to give you sodium carbonate plus water plus carbon dioxide. It is 2 NaHCO3, 1 mark to give you Na2CO3 plus H2O plus CO2, 1 mark, plus the last mark for the balancing, 1 mark for the reactants, 1 mark for the product, and 1 mark for the balancing. If it is not balanced, that simply means the learner will only get 2 marks, 1 mark for the reactant, 1 mark for all the products given, and then you'll take the mark for the balancing. The question 9 was out of 32, and that is the end of our grade 10 June Technical Sciences 2023 paper. Any questions, any inputs, colleagues?
Just move it up a little bit for one to capture 952 for the ones that are going to watch later. Thank you very much. Colleagues, thank you very much. Let me just say, any inputs, comments on question 9? Any inputs, comments, question 9? I don't see any.
Yeah. Okay.
Yes, Ntate Isaac.
Yeah, Ntate. I see the mark allocation there. It is for the product and for the reactants and for balancing. So now, do I award the learner a mark? Copy the same equation and then balanced it correctly.
I want to try and understand what you are saying, sir. Let me check.
Okay. You say
now the equation says write down the balanced chemical equation for the following. So at 9.5, they are given in weights, which is now zinc plus oxygen. So you give now for Zn plus O2. But for us to give that mark of Zn plus O2 before the balancing, that mark of Zn plus 2, for us to give, there has to be an arrow. That arrow will indicate that now these are the reactants. If the arrow is not there, unfortunately, we'll need to penalize. Because what informs us that it is a reaction is us having that specific arrow there. Then the product side is written as zinc oxide in weights. Then you give a mark for the learner to say ZNO. Once the two are there and they are correct, then you can give a mark for balancing, provided that the balancing is also correct.
Okay. Yeah, because now the symbols must be there, but the learner, what the learner did, just wrote the 2 and 2 there without the symbols.
Not correct. For us to give now the balancing mark, it must be in the correct reactants, correct products, then we can award a mark for balancing. So basically, if the 2 is there, what is it that this learner is balancing? Nothing at all.
Okay.
Thank you very much, sir. Any other inputs, colleagues? If there are no any other inputs, colleagues, I must say the register is very, very slow. There's only about 15 people here, including myself and Mebusi. It means there's now 13 of us, but we are 20 in this particular meeting. Colleagues, once we close this particular session, it means you'll not be able to access the register. Hence, I am quickly requesting you to complete this particular register, because the thinking is even if you are going to watch the video later, you'll still need to fill it in. So what I'm going to do is I'll put it in the description for the video on YouTube for those that are now not here, not necessarily in the group, because now other people will now complete it even though they did not attend this particular session. That is the reason why we only share it with you, so that we can be able to monitor those who attend and those who do not attend. So colleagues, if there are no any inputs, I would like to give to Memanchu to give now words of thanks, and then basically we can conclude this discussion of technical sciences junior examination grade 10. Memanchu.
Good morning again, colleagues, and thank you very much for your attendance in this particular marking guideline discussion. The reason why we need you here, colleagues, is for us to ensure that we rectify the learners' mistakes such that by the time we reach the final exam, they already we have already removed the misconceptions, the mistakes that they normally make, so that at the end of the year they get the marks that they want. So please, colleagues, let us not be lenient now. Let us be strict now, so that they are able to rectify the mistakes. Remember, if you tell them, if you don't do this, you are not going to get marks, and then we come now give them marks for what we're saying we are not going to give them marks in the future, learners won't be able to learn. So it is important for us to make them learn now, and then later on they know what they need to do. Thank you so much, colleagues, and with all that, good luck with your results. I hope the learners will pass, and good luck with everything that you do at school. We know that it is not easy, colleagues, and we acknowledge your hard work. Thank you for your hard work. It is not always easy to complete the syllabus. It seems like the year just goes by so quickly. So your hard work does not go unnoticed. Thank you very much for everything that you do for your learners. Thank you very much for all the extra mile that you always go with your learners. It is much appreciated. Thank you, colleagues. Have a lovely day. For me and my colleagues, thank you so much. Goodbye.
Thank you very much, Mebusi. Colleagues, thank you very much. Just complete the register, as I repeat again. Thank you, Mezapi, for being here also. Colleagues, now after marking, basically, there has to be a link of error analysis. Kindly also complete the error analysis. It will be available very soon. Kindly complete the error analysis, because it's what now informs us in terms of how best can we improve as a subject, and the gaps that are there now you are experiencing at schools for us to have a certain type of intervention for that. But if you do not complete the forms, colleagues, like I said, it makes it very difficult, because we'll be only working with a small data, which basically represents maybe only 2-3 districts out of 5. So once that link is available, I will also share it in our groups. And for me to you, colleagues, I will also say thank you very much for all the hard work, and let's keep on going. Let the great Lord give us strength now to survive now everything that is coming our way. With that being said, ladies and gentlemen, thank you very much and have a lovely day.
Thank you, Ntate Nambane. Thank you, colleagues.